Hello everyone. As you all know that CBSE has introduced Maths Advanced for grade 9 and it is an optional subject, like those students who are interested they can opt for it, and those who doesn't want they cannot opt. So in this video I am going to discuss about chapter 1, which is sets. So I will be providing the introduction of the sets chapter as well as I will give the answer for the exercise 1.1 and 1.2. So this sets chapter is a very easy chapter and it is very easy to understand also. So let's begin the class. So first of all, we'll see the definition of a set. So a set is a well-defined collection of objects. The objects which belong to the set are called its members or elements. So what is the meaning of well-defined here? For that, I will give you one example. Suppose you have to find the collection of all intelligent students of your school. So this is not well-defined because a student may be intelligent for one teacher, they may not be intelligent for another teacher, isn't it? So the set should be well defined, means it should give the same meaning to any person. And the object which belong to the set are called its members or elements. So when we represent a set, okay, so there are two ways to represent it: roster form and set builder form. Now roster form is also known as tabular form. In this method, we list all the members of the set within braces, usually curly bracket, and separate these by commas. So let's take one example. Suppose we have to write a set A of all odd natural numbers less than 15. Okay, so two things are there. First, it should be odd natural number. Second, it should be less than 15. So the numbers will be 1, 3, 5, 7, 9, 11 and 13. So you have seen the definition here. Here it is given: the objects which belong to the set are called its members or elements. So these 1, 3, 5, 7, 9, 11 and 13 are called the members of set A. Okay. Now see, it is well defined. Why? Because if you ask from anyone the same question, they will give this answer only. Okay. It's not like other person will have some other answer. So this is a well defined set. So first one is roster form. Now second type of representation is set builder form. This is also known as rule method. In this method we write a variable, suppose x, representing any member of the set followed by a property satisfied by each element of the set, and this is also encloses it in braces. Or in this method we specify the elements of the given set by some description. So let's understand this with the help of an example. So suppose here I have given a set, the name of the set is V, where the members are A, E, I, O, U. Now if I have to write this in the set builder form, so first it says first you have to write a variable, say X. So I have written a variable X here, and then you have to give some property or you have to give some description. So if you see A, E, I, O, U, these all are the vowels of the English alphabet. So here you have to mention where X is a vowel in English alphabet. Okay. Now the symbol this stands for the word such that. Okay. Sometimes we use the symbol colon also in place of this. Now how we read it? We read it as the set of all elements X such that X is a vowel of the English alphabet. Okay. How to read it? The set of all the elements of X such that, this line meaning such that X is a vowel in English alphabet. Okay. Now I have given few questions. Write the following sets in roster form and also in set builder form. So factors of 48. So find out in which table this 48 will come. Those all will be the factors of 48. So the factors of 48 you can write. It will come in one table. So 1 into 48 is 48. So 1 and 48 both are the factors. Then in 2 table 2 into 24, isn't it? So 2 is also a factor. 3 table 3 into 16. So 3 and 16 is also a factor. 4 table 4 into 12. So this is also a factor. Then 6 table 6 into 8 is also. And then after that 7 table it won't come. Again it will start coming in 8 tables. 8 I have already taken. Now these are the factors of 48. Right. So when we have to write the factors of 48 in roster form, we have to just write these numbers 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48 in curly braces. Right. So this is your roster form. Now set builder form, you have to write the set of all elements of X such that X is a factor of 48. So just you have to give a description of it. Okay, now I have given one question so that you can practice this question. You have to write this in, you have to represent it in roster and set builder form, and please give the answer in the comment box. Now let's see the other definitions. Now the theory of sets was developed by German mathematician Georg Cantor. So he is the person who has developed this, and he is considered the founder of the set theory. Okay. Now next we will see different types of sets. Okay, so the first is finite set. Finite means something which you can count. So a set that contains limited or definite number of different elements is called finite set. For example, there is a set A and it has the member red, blue and green. So it has 3 members, so it's a limited. The other example I have given, X, the set of all elements of X such that X, this symbol means I have given belongs to, X belongs to whole number, and there is a condition, it should be less than 1000. Okay, so less than 1000 means you have to go till 999. So this is also fixed, it's limited. So these all type of set comes under finite set. Now next is infinite set. A set that contains unlimited number of different elements is called an infinite set. In other words, the sets which is not finite is called infinite set. So the example is the set of all natural numbers. Okay, so natural number there is no end, isn't it? So it comes under infinite set. Next is singleton set, a set that contains only one element. Single means one, okay, or unit. So we call it as singleton set. For example, here only 8, or months of a year having less than 30 days. Less than 30 days is only February. So it has only one member. So we call it as singleton set. So hope whatever I am explaining it is clear to everyone. Still, if you have any doubt, you can write to me in the comment box. Now next is empty set. A set which does not contain any element is called empty set. It is also called as null set or void set, and it is denoted by this Greek letter phi, or you can just put 2 curly braces. Okay, so this means empty set. An empty set has no elements, so it is a finite set. For example, prime numbers between 13 and 17. Now see, between 13 and 17 you have 14 and 15, but 14, 15, 16. But 14, 15, 16 is not a prime number, so you will not have any member. So we say this is an empty set as it doesn't have any member. Now the next is, see, in the curly braces 0 is given and pi is given. This is not empty set because each of these sets has one element. Here is 0, here is pi. Okay, so this doesn't come under empty set. This we can say it as singleton set as it has one member. Next is the order of the element in a set is important. The elements of a set distinguish the set, not the order in which the elements are written. Thus the 3 sets 1, 2, 3, 1, 3, 2 and 3, 2, 1 are the same set. So what does it mean? The order of elements in a set is not important. You can write in any order. Okay, only members is important. Can a set have repeated elements? No. Set containing letters of the word banana. If you see here, A and N has come multiple times. So repetition of element is not allowed in a set. So if you have to write the letter of the word banana, you have to only write the letters which is different. So B, A and N. Okay, only this you have to write. Next is equality of sets. So two sets A and B are called equal sets, which is written as A equal to B if they have the same elements. Okay, and if two sets are not equal, we write A not equal to B. So let's see the example 2, 5, minus 1, 0, and here also 0, minus 1, 5 and 2. If you see in both the cases, it is same members, just order is not same. So we call this as equal set. Here also 2 and 7 are repeated. So actually the members are 1 to 7 only. So this is also equal set. Next is equivalent set. Two sets are said to be equivalent if they contain the same number of elements. See, between equality and equivalent there is a difference. In equality set, members should be same. Okay. But in equivalent set, how many members are there? The count should be same, not the members. So here I have taken two sets. Set A is having 3 member 1, 2, 3. Set B is also having 3 member 4, 5, 6. So both are equivalent because both have same number of elements. See, NA and NB means it is talking about how many members it has. So the first set is having 3, second set also having 3 members. So both are called as equivalent sets. Okay. Now let's start with the exercise. The first question is list the elements of the following sets. So the set of all element of x such that x is an integer and x square equal to 9. Now see, x square equal to 9. For which value of x it is 9? It can be either 3 or minus 3, right? So the answer will be 3 and minus 3, right? And you have to take both because it is given x is an integer. Next is x such that x is a positive integer less than 5. So the answer will be 1, 2, 3, 4. Okay, it is talking about positive. Now 0 we cannot take because 0 is neither positive nor negative. So it is only 1, 2, 3, 4. Next, x is an even natural number divisible by 5. So it should be even also, it should be divisible by 5 also. So the answer will be 10, 20, 30, 40, 50 and it is an infinite set. See, A and B is finite set because it has limited number of elements, but C option it has infinite elements. Okay. Next, x belongs to natural number. This symbol means natural number and x is less than minus 1. Now, this is an empty set. First, it is talking about natural number and it is less than minus 1 means nothing will come. So, it's an empty set. Now, question number 2. Determine which elements of the set from here are natural numbers and whole numbers. So, from here, natural number starts from 1, 2, 3, 4 and so on, right? So, natural number is nothing. So, none. Whole numbers, only 0. Next, you have to find integers. So, integers will be minus 5 and 0. And rational number means number which is written in the form of p by q. So, it will have minus 5, minus 1 by 2, 0, 2 by 5. All the decimal number also comes under rational number. So, 13.4 also, 1 by 3 also, 19 by 2 also. So, they all are rational numbers. Next, real numbers. Now, real numbers include all the numbers on the number line, whether it is rational or irrational. So, under real number, you will have all the elements. Okay. So, whole set A, all the member will come under real numbers because real numbers include rational number as well as irrational number. Now, question number 3. Write the following sets in roster form. So, set of all element of x such that x is a 2-digit number and sum of the digit is 5. So, the answer will be 14 because 1 plus 4 is 5, 23, 2 plus 3 is 5, 32, 3 plus 2 is 5, 41, 4 plus 1 is 5 and 50, 5 plus 0 is 5. So, these are the options. Next, you have to find the set of all elements of x such that x is an integer and mod of x is greater than equal to 9. Now, mod of x greater than equal to 9 means the distance from 0 is 9 or greater. Now, this you have to always remember this splits in two inequalities. Okay, it should be x is less than equal to minus 9 or x is greater than equal to 9. Okay, so x is less than equal to minus 9 means it will come minus 12, minus 11, minus 10, minus 9 and after minus 12 also so on. For x greater than equal to 9 it will be 9, 10, 11 and 12. So if you combine, so this will be your set. It will start from infinite to other infinite, but the elements included will be minus 11, minus 10, minus 9 and then 9, 10, 11 and so on. So this equality you should know how it is getting split. Next, the letter of the word sweet. So S, W, E and T. The letter if it is repeating you should not write. Here x equal to n plus 1 by n where n is a natural number and n is less than 6. So less than 6 means 1, 2, 3, 4, 5. So for 1, 2, 3, 4, 5 you have to put the value as n and then you have to get the member. So n must be natural number. We know natural number starts from 1, 2, 3, 4, 5 and so on. And there is a restriction that it should be less than 6. Less than 6 means only 1, 2, 3, 4, 5 only you have to take. So use this formula and substitute n as 1. So when you put n as 1, you will get 1 plus 1, 2 by 1 which is 2. When you put n as 2, you will get 3 by 2. When you put n as 3, you will get 4 by 3. And when you put n as 4, you will get 5 by 4. And when you put n as 5, you will get 6 by 5. So the sets members will be 2, 3 by 2, 4 by 3, 5 by 4 and 6 by 5. Next, set of elements of X such that X is a composite number. Now composite number is also infinite. It is starts from 4, 4, 6, 8, 9, 10, 12 and so on. Next, write the following sets in set builder form. It is 2, 4, 6, 8 and so on. So we can write this in two ways. Either you write the set of elements of X such that X is an even natural number, or you can put it like a condition. Okay, X equal to 2n where n is a natural number. Natural number means it will start from 1, 2, 3, 4. So replace n with 1. 2 into 1 is 2. 2 into 2 is 4. So you will get this set only. Next, 3, 6, 9, 12 and 15. So it is, again this you can write in two ways. First you can write x equal to 3n where n is natural number and n you have to take from 1 to 5 because it is still 15. Or x is a multiple of 3 and it is between 3 to 15. Okay, so like this you can give a range also. Next, 1, 4, 9 and 16. See, these are square numbers. So you have to write x equal to n square where n belongs to natural number or x is the square of a natural number. Next, 8, 9, 10, 11. So you can write x is a natural number and x should be greater than equal to 8 or x is a natural number greater than equal to 8. So either you can put like a symbol or you can write a full description. Both is fine. Next, 1, 2, 3, 6. So this is nothing but the factors of 6. So you can write x belongs to natural number and it is a factor of 6, or you can write x is a positive divisor of 6. Next question is, can two different sets have the same roster form? So no, two different sets cannot have the same roster form. If two sets share the exact same roster form, means they are mathematically identical and equal sets. Okay. Two sets are equal if they contain the exact same unique element regardless of the order of appearance or repetition of elements. Now we'll move to question 5. Which of the following pairs of sets are equal? So if you see here, you have member C, D, E, N and T. Here also same member, so it is equal. Second one also equal. Third one, x is a 0 of the polynomial x square and second one is the root of the equation x square equal to 0. So for both, if you see, the roster form is 0 only. So this is also equal. Because is 0 of the polynomial x square means what? Which value of x will make this polynomial 0? It is 0 only. And root of the equation x square equal to 0 is also 0. So both have the same member which is 0. So they are equal set. Next, x has numerical value less than or equal to 1 and x is the root of the equation x square minus 1 equal to 0. So for the first one, you will have the member like this and the second one member is only minus 1 and 1. So they are not equal. Next is 5, 10, 15, 20 and here is 5, 10, 15, 20 and so on. Again, this is not equal because one is finite set, one is infinite set. Okay. So this is also not equal. Next, 5 and braces and inside that 5. This is not finite because first one is null set but the second one is telling a set having one element. Null set means nothing is there, and but the second one it says it has one element 5. So this is also not equal. Next, state which of the following sets are finite or infinite. So it is given x belongs to integer and x minus 1 plus 2 x minus 3 equal to 0. So from here you will get the value of x as 1, minus 2 and 3. Okay. So you have got 3 members. So it is a finite set. Next, x is 2x and 2 are co-prime. Okay. So the number 2 has only one prime factor 2. Therefore, x cannot be divisible by 2. This means x must be an odd integer. And odd integers can be all these. Okay. For see, x can take any value from here because if you will take minus 5 and 2, again they are co-prime. Minus 3 and 2, they are co-prime. So it doesn't have any end. So this is infinite set. Next, x is a rational number between 3 and 4. We already know between any two numbers, you can get infinite rational number. Okay. So this is infinite. X is an integer and mod of x is greater than equal to 5. So again, greater than equal to 5 means x will be less than equal to minus 5 and greater than equal to 5. So the members will be infinite. Okay. Next is subset. See, we have covered exercise 1.1 all the question. Now I am moving toward another exercise, but before that I will explain some of the concept. So what is the meaning of subset? Subset means if all the elements of set A belong to set B, then set A is said to be the subset of set B. Let us understand this with the help of an example. So I have taken set A which has member 5, 6 and 7, and set B has a member 2, 3, 4, 5, 6, 7. If you see, all the members of set A is present in set B, right? 5, 6, 7 is here. So I will say here set A is the subset of set B, okay? Because all the elements of set A belongs to set B, and this is the symbol of subset. Okay, and it is you have to read it as A is a subset of B or A is contained in B. Next, then what is proper subset? The set A is said to be proper subset of set B if all the elements of set A are contained in set B and there exists at least one element in B which is not in A. Okay, it means the previous example whatever I have given, this is proper subset because 2, 3, 4 are the element which is not present in A. And only proper subset if you have to write, you have to put this symbol and it is read as proper subset. A set A is proper subset of set B. Next, what is the meaning of cardinality of a set? Cardinality means the number of distinct elements in a finite set is called cardinal number. For example, if I have taken a set A, it has 3 members C, D, F. So the cardinal number of set A is 3 and we have to write it as NA equal to 3. Now another example, B equal to 1, 2, 3 up to 9. So it has 9 members, so we will write NB equal to 9. Number of subset and proper subset of a given set. The number of subset of it will be 2 to the power n and number of proper subset will be 2 to the power n minus 1. Okay, now I have given one table where first one I have taken 5. 5 does not have any element, so it is 0. Number of subset 2 to the power n means 2 to the power 0 which is 1. Okay, number of proper subset 1 minus 1 0. Subsets also nothing because it is null set. Now next see number of elements, here it is 1. So number of subset will be 2. Proper subset will be 1. Then what are the subset? Phi and A. Now see phi is a member of all the set. So phi you have to include. And when you say proper subset, you should not include the whole member from the given set. So A will not be included, only it has one proper subset. Next, second one, it has 2 members. So number of subset is 2 square equal to 4 and number of proper subset 2 square minus 1 which is 3. Now what are the subsets? Subset will be phi, then A, B and the combination of A and B. But in proper subset you should not take this combination. Okay, the whole member you should not take in proper subset. Next, ABC, it has 3 members, number of subset 2 cube equal to 8, proper subset 7. The members will be phi, A, B, C, then all the combination A, B, B, C, A, C, and then A, B, C. And in proper subset, the last one, A, B, C, you should not take. Now, universal set. It is the set which contains all the sets under consideration as its subset. Universal set is denoted by U. So, let us take an example. I have a set A, members are 5, 6, 7, 8. Then set B, members are 1, 3, 5, 7 and set C, members are 4, 6, 8 and 10. Then the universal set for these sets taken as combination of all the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See 2 is not here but you can include 2 also. So this is the universal set for A, B and C. Universal set of natural number, whole number, integers, rational number, irrational number is real numbers because real number will include all. Next, what is power set? A power set denoted as PA is the set containing all possible subsets of a given set A. So if a set has n element, the power set content will exactly 2 to the power n element and the empty set and the set itself are always included in the power set. So power set of A equal to 2 to the power 3 which is 8 because it has 3 members. And how to write the power set? It is 5, 0, 1, 2, 0, 1, 1, 2, 0, 2 and then 0, 1, 2. So it has 8 members. Now exercise 1.2. So here if you see question number 1, fill in the blanks with symbol subset or not subset. This is the symbol for not subset. So first one if you see 2, 3, 4 and 2, 3, 4 is present in this set also. So it is subset. So you have to just put this symbol. Second one is, first set are triangles in a plane, second is polygons in a plane. Now all the polygons, under polygon you will have triangle also. So this is also a subset. Okay. So here you have to write it is subset. Next is x is an integer, and here it is given multiple of 4. So many integers like 1, 2, 3 are not multiples of 4. So this is not the subset. Next, 5 and, so the empty set 5 is always a subset of any set. So this is also subset. Next, x equal to m minus 1 by m, where m is a non-zero integer and then the other one is x is a rational number. So m and m minus 1 are integers. So the fraction m minus 1 by m always result in a rational number. So this is a subset. Now next one, x equal to n square and x equal to n cube, means any natural number square here and here cube. So like natural number square is 1, 4, 9 and 16, and cube will come 1, 8, 27. So it is not included, right? It's not a subset because 1, 4, 9 doesn't come under the cube of the natural number. So this is not subset. Next, x belongs to real number and x is equal to 2 to the power n. Now for this, the set of real numbers contain infinitely more numbers like 3 or 5 than the specific power of 2. Now see, the meaning is, here you will have members like 2, 2 square, 2 cube, 2 to the power 4 and so on. But real number will have many numbers. All the number is not present here because it takes only the number having power of 2. Right? So it is not a subset. So uh, 2 to the power n means what? It will have the number 2, 4, 9, 8, 16 and so on. But real number will have many things, negative number, positive number, 0. So it doesn't come under this. So it is not a subset. Next is determine whether the following statements are true or false. So it is given 1 belongs to set 1. So it is true because the number 1 is an actual element listed inside the set. Next, this is false because the left side is a set containing the number 2, but the right side only contains the raw number 2 as an element. It is not a set. Here, yes. See, this along with the braces 2, it is present in this set. So this is true. See the difference. Here, it is talking about this complete set that is not present here. It has only 2. Okay. Now 5 belongs to 1, 2, 3. False. The set 1, 2, 3 contains only the numbers 1, 2 and 3. The empty set symbol is not listed inside it as an element. So it doesn't belong to this. Next, 5 is a subset of 1, 2, 3. This is true because empty set is always a subset of every existing set. Write the power set of the following sets. First is 1. So number of elements is 1. Total subset is 2. So the power set is 5 and 1. Next, P and Q, members 2, subset 4. So these are the power set. Next, 1, 2, 5. So members 3, total subset 8, and these are the power elements. Next, here members are 2. So subset will be 2 square, which is 4, and these are the members. Next, what is the cardinality of the following set? Cardinality means how many members it has. So first one, only one member. Second one, 2. Here 4, here 3, here also 3. Next is let A be a set and number of cardinality of set A is 10. Then find the value of NPA. What if A has 100 elements? So always remember this, if a set A has NA equal to K elements, the cardinality of its power set is given as this formula. So first one you see, it has 10. So replace K with 10. So first case 2 to the power 10, which is 1024. For the second one, if it has 100 elements, then it will be 2 to the power 100. Okay. So I have covered all the questions here now. So